Hello everyone, welcome to your engineering solutions. Today we're going to state the order of the given ordinary differential equation and state whether the equation is linear or non-linear. So before we go to solve these problems, please pause the video and look at the examples that I have here for you in order to define what the order of a differential equation is, as well as what does it mean for an ordinary differential equation to be linear. I also provided here some examples so you guys can try them out. And now let's start with the first problem. So you can see for the first problem, in order to state the order of a differential equation, we just have to take the highest order. So we know that y double prime is the highest order, so this is a second order ordinary differential equation. To see if this differential equation is linear or non-linear, we can put it in this form. We can say that 1 minus x is a of x, y double prime plus b of x, y prime, plus, we can say 5y is equal to g of x. As we can see, this form is linear because of the examples that I have here above. And yes, so this ordinary differential equation is second order ordinary differential equation as well as linear. Okay, next problem. Then for this next problem, we can see that this is a fourth order differential equation because this is the highest power order, and then we can put it once again into the form that we had before to see that if this equation is linear or not. So you can see this equation is linear, so the problem is solved. It is a fourth order ordinary differential equation as well as linear. Go to the next one. Now we have a more difficult problem. So in order to see if this is what order this is, you have to rearrange both sides. So you're gonna square both sides to get this. All right, now we're gonna move dy over dx squared to the left. And now we can, oops, I forgot the squared here. And now we can see it, well, first of all, we can say that this is a second order ordinary differential equation, as these are just exponents. These do not mean derivatives. These are just exponents. Okay. And well, now if we put it into the form of, well, we can see, okay, we have y double prime, and then we have this squared minus y prime squared is equal to 1. As you can see, this is not going to give you a linear function. So this problem is solved. You can say that this is a second order ordinary differential equation and is not linear. Once again, it's very important that you guys are familiar with this format so you guys can put all of your equation to this format and you guys can figure out if it's linear or not. So if you guys don't feel good in or don't understand what I'm doing, it's very important that you guys know that equation so you guys can keep up with the problem. Now let's go to the next one. We have sine of theta y triple prime. So we can see that straight up that this is a third order differential equation. Then we can rearrange it into the other equation. So we can say a of theta y triple prime plus b of theta y prime is equal to 2. So we can see that this does follow the equation that we had above. So this is a linear ordinary differential equation. Now we have this. So what makes this problem different is now we have to see if this is linear or non-linear in both y and x. So what we can do is, well, we first have to rearrange this equation. So we're going to first solve it for y. What we're going to do is, first of all, I'm going to rewrite this equation. So we have down here, we want to have dy on the top and dx on the bottom. So we're going to divide this whole thing by dx. And then now we can see that we have dy over dx. So this is, we know from the start that this is a first order ordinary differential equation. Now if we go to the next step, we want to find out if it's linear or not. Well, I'm going to rearrange this again. So we have x, actually I can write that as y prime plus y squared minus 1 is equal to 0. Well, if I write this equation as previously, I'm going to have a of x, y prime plus y squared minus 1 is equal to 0. As you can see, this term right here is not linear, as y squared is not gonna give you a linear is not a linear function. It's a parabola, so therefore it is non-linear. Now that was for y. Now if we want to solve for x, now we have to rewrite this. So now we want to have dx over dy. So now we want to divide both sides by dy. So we're going to have y squared minus 1 dx over dy plus x is equal to 0. Now, once again, we can see this is a first order ordinary differential equation. So now I'm going to rewrite this equation as previously, and I'm going to have a of y x prime plus x is equal to 0. Now we can see that each term is linear in x. So this right here is linear in x. So what we have is, in y, it is a first order, and it's nonlinear. And in x, it is also a first order, but it's linear. So if you guys have any questions, please let me know in the comments below what questions you guys have, and hopefully I can explain this better in a future video. And thank you for watching. Bye bye.